So today we're going to talk about some basics about fasteners, bolts, machine screws, Loctite, vibrational surfaces, and then different methods for attaching fasteners to make your robotics projects a little bit stronger, a little bit more efficient, and help speed up your process. So let's talk fasteners, bolts, machine screws, whatever it is you want to call them, whatever these guys are. And first thing you need to know is what kind of tools can you use for using fasteners to fasten objects together. You can use an adjustable crescent wrench. Problem using adjustable crescent wrench with heads that are all the same size. This is useful if you're constantly changing sides, but it can get really frustrating if you're working with a constant diameter nut the entire time. So not my favorite tool to use. You can use nut holders. These are really helpful because there's a couple different ways that you can hold a nut in place. And typically there's enough space there so that you can drive in a pretty long bolt without having to worry about running into issues. There is also a crescent wrench, a spanner, depending on where you are, that can hold in either on this side or hold in on this side at the back. My preference is using the back here because you get more points of contact. It makes it a little bit easier to line up than using this head. As far as actually screwing them in, you've got a sort of T-shaped hex key that you can use. This has two different sides, so one for torquing like that, the other way for turning this way. You could use a small hand drill. Make sure you're not over torquing things. The other thing you can use is an L-shaped Allen key, which is this guy right here. These are useful for certain situations because at the end they've got a ball joint. And what a ball joint allows you to do is, let's say I were to attach this fastener on the inside here. The nice thing about is that on this end I can get lots of torque, but sometimes if you're coming straight in, you have to typically screw in at an angle. And what a ball joint lets you do is it lets you thread in on an angle instead of having to be straight up and down. So a ball joint can be really useful for putting things together. So let's imagine that I want to take this sonic hub and I want to attach a gear to it. In order to attach these two together, I'm going to want to make sure that I'm using the correct size bolt for the job. I have this handy dandy bolt sorter here. What it lets me do is it lets me take a bolt and it lets me write it down in on the top, and it will roll down until it gets the correct size that I'm looking for. So I'm going to grab this. You want the shortest bolt for the job that you need. So if I were to run in and I'm going to select something that's going to go all the way through my first unit and most of the way through my second unit, and that looks about right. You don't want to use too long of a fastener because then obviously you're going to go clear through, and that's not useful. It adds additional weight that you don't need. Another reason is if I use too long of a fastener, it means that I'm spending all day sitting here and spinning until the cows come home. So you only want to do as much work as you need to on your job. That can be really, really useful. So that's my first tip. Next one is if you're going to go in some sort of porous material or some sort of material that's not super hard, like a metal or a steel or aluminum, something along those lines, you're going to use a washer. And what a washer does is it allows you to spread out the force of your head. So if I look at the bolt head here, I've got a diameter of about 4 millimeters. But when I run this washer on, I've got a diameter of 6 millimeters. And when I spread that force out, it's going to allow my fastener to stay on a little bit better. Now on this part, I'm likely going to be attaching this part to a motor. And on my motor, I'm going to be facing a lot of vibrational forces. Two ways you can get rid of a vibrational force. And obviously vibrational forces are bad because what can happen over time is you can actually start to loosen the bolt off and it will start falling out. I'm sure you've probably had that happen in some of your projects before. Two ways you can get around that. The first way is using something called a lock nut, sometimes called a nylon lock nut. If you look on the inside of this lock nut here, there's a little piece of plastic. Sometimes it's blue, sometimes it's white, and that's nylon. And what'll happen is when you thread a bolt inside, this bolt is actually going to catch on the inside of that nylon, and it's actually going to cut inside that nylon. And because that nylon is actually going to cut itself into the grooves here, it will stop and it will resist some of that force to want to back out, some of that vibration. So a lock nut can be really helpful. But occasionally you run into a situation like this, where there's no real place for me to put a lock nut at the end. So instead I'm going to use something called Loctite or Threadlocker. Loctite is the brand, but a Threadlocker is actually going to lock our threads in place. So what I can do, there's two types of Threadlockers, or at least for Loctite. There's Loctite Red and Loctite Blue. Loctite Blue is the normal hold, and it comes in a red bottle with a blue label. And Loctite Red is the strong hold. It comes in a blue bottle with a red label. It's a bit confusing, but you'll note it is the blue liquid. For most things in robotics, and FTC at least, a blue is more than sufficient. This is going to come out faster than you think. We're going to squeeze maybe a small drop, maybe 0.5 millimeter on the end here. And that might have been a little bit too much to pop up. Sorry, I got out of focus of the camera there. So I only need just a little bit. Let's see if I can get it focused in. Come on, there we go. You just need just a little bit. This is probably too much, honestly, to throw on. I probably need about half that. And you want to put it near the end of your bolt so that when I go to thread this in, what's going to happen with that thread locker is as it dries, it's going to expand out and fill in those threads and kind of lock them in place so that they're not going to want to back out. So anything that's going to be facing vibrational forces, like on a robot, should be having some sort of thread locker, a lock nut, or Loctite inside. The next piece of advice, let's say I want to put all 4 of these on. You already saw me struggle with it a little bit earlier. You want to do hand tight on all your bolts at the start. I like to put my bolts in on a cross pattern, and then I'll just do a little bit of hand tight. I have run out of washers here, so I'm not going to use washers on the last 2, but that's okay. Just for demonstration purposes. I'm going to get hand tight in on these. And once they're all hand tighted in, then I can come back with one of my tools and tighten them up in a cross pattern. So I can torque that one up, come down, torque that one up, come over in a cross pattern, torque that one up, and then torque that one up. The reason you want to go in a cross pattern or a plus pattern is so that your part is always equally compressed down. If I'm doing in a circle, what can happen is sometimes your part will end up being a little bit warped, and that's not going to be super beneficial for you to not have a straight part. So a cross pattern is a great way of tightening something up. Doing it hand tightening it at the start as well is for proper alignment. So if I were to back some of these out, one problem that can happen is if I put in one bolt and I tighten it up really, really tight right at the start, I get nice and torqued, what can happen is that I can misalign some of my holes. So when I try to get this in, I'm not actually able to get my threads in. So by leaving it just hand tight at the start, it allows me to get a little bit of wiggle room on my bolt there, or on my 2 components, so they can actually connect. The last piece of advice I'm going to give you today with fasteners is that you want to have the last object in the system to be threaded. So if you look at this, this is a threaded hole. This is a non-threaded hole, or a clear hole, or a through hole, sometimes it's called. You always want the last item in your system to be the threaded. And here is why. You don't want multiple threads in a system. And I'll give you an example with a long bolt here. Let's say, for example, I'm trying to connect these 2 together like so. So I hand tighten up this bolt, I throw this on, and now I'm trying to put my nut on like so. The problem is, I've got a threaded system here, a through hole, and a threaded system here. So if I were to try to put some other system in here and I try to tighten this bolt head down, there's nowhere left for it to go, because it is wanting to suck down into these threads and into these threads at the same time. And once it bottoms out at the top unit on the system, there's no way for me to get these in tighter. And yes, you can say that, sure, I could come along and I could tighten this one, like so. But the problem with that is that I'm still going to be only tightening in on one side, and I might not be able to tighten this side. Or, as a even greater example, oh man, I'm having struggles holding on to my parts today. As an even greater example, if I wanted to connect multiple parts together, like so, what can also end up happening is that as you thread these together, you can bottom out in the middle of your system too, before you end up having time to actually tighten it up. So this is a pretty common scenario that can happen. You're not tight, not tight, not tight. And now there's no way for me to spin this all the way to get that tight. So instead, what you want is the last item in your system should be a threaded. So for instance, if I were to attach this is kind of silly to attach a gear onto here, but I could have through hole, and then I can attach a nylon lock nut here. But it looks like I would actually need a slightly longer nut on this one, because if I were to tighten this up, I don't have quite enough space to actually get into the top of that nylon lock nut. So this would need a slightly longer bolt in that case. But that's a bit on Fastener 101. I hope that can help you not only speed up your projects, but also reduce some of the weight and stop some of these darn fasteners from falling out of your robots projects all the time. So best of luck, and I'm looking forward to seeing what you make on your next robotics project.